BIM coordinator, respectively, sorry, in projects like the Feyenoord Stadium in Rotterdam, Netherlands. So this stadium particularly, which is home to the football club of the same name, was made possible implementing computational design during its, let's say, initial processes and to meet their objectives. Our guest was an important part of this process as he helped the design team develop the mindset required to be able to not only understand what type of questions, but also make them and make this entire design workflow possible. The end result was a one-of-a-kind project that serves as a blueprint, not only for other projects in architecture, but also for future projects of OMA. And he also was a part of another project, which is the Calle de Way in Vienna, which is a project that is reminiscent of the architecture of the Vienna Secession. This department store is made up of 2 volumes that are connected by a green buffer zone that integrates itself into the passageway and make room for roof gardens and more public spaces that integrate seamlessly into the pedestrian network, let's say, of the historic center. But his professional experience doesn't stop here, because he also is the founder of Macro for BIM, which is an organization that aims to create tools to help the work of architects become more efficient and more intelligent. So thank you for joining us today, Giuseppe Dotto. How are you doing?
Thank you. Thank you very much. And thanks also for the introduction, like a couple of rows on some of the last years of my career. And all good here. As you were saying, I'm joining from Amsterdam. Maybe you can guess it's also sunny, which is special, which makes this day very amazing. All good here. Thanks. Ciao, everyone.
Perfect. Thank you. I'm really glad that you're doing all right. So we have a busy schedule ahead of us. So shall we start?
I think I don't know how many people in the room, but ready.
Excellent. So let's begin by talking experience. Let's go back to the very first point of your career journey. Can you share with us a little bit of what was your first architecture job like, and how do you manage to go through the first very challenge of taking on this endeavor?
Yes. Okay. We will start from the very, very beginning then. My first architectural job, I was looking like a little disclaimer I have to do. It's that I hadn't reached the master, so I was still studying at university back then. When I'm talking about what I still consider my first job in architecture, but funny enough, it was teaching. And it was teaching Revit, actually. It was very specific, the things. But it was, I consider this as my first job in architecture field, because it gave me the possibility of understanding little by little that us, architect, we need to make strong use of computer, and just by, for example, knowing a tool, that in my case was Autodesk Revit, we can somehow find some path or some careers, right? Then thanks to this job, of course, I end up knowing so well this tool to be able to then join other challenges, and I can just make some jumps over the time in different companies. Also after, of course, my graduation, where this application of computer was done for a practical matters and for real deliverables. I've been lucky enough since the very early stage, working with offices that were embracing the BIM, if that makes any sense to you, but in general that were making part of BIM deliverables. And so as a first approach to architecture, yes, and wrapping up the answer, I would say teaching the tools for then applying all the technical knowledge I knew for the practical and architectural knowledge that was then needed later on. this is how how everything started. And it was already kind of clear back then how then my career would have been more towards a technical field, where definitely the strong use of digital tools, in my case at least, would have been a important main character all over the career path.
Excellent. So around when was this first opportunity you have?
Okay, I was teaching Revit 2014, sorry. So I guess it was around 2014. That's the things. Yeah. 2014. Yes, I remember 2014. The then after it happened an update, and we teach again, but the newer version, because it was a big gap. Well, not a big gap, but a huge improvement on the software on those years. I remember. So was this we're talking about not so long ago.
Yeah, perfect. So, I mean, we have discussed this in the past, but you seem to be pretty acquainted with BIM already, and I mean, not only on your projects, you also delve into this heavily, but for those of us who may be new to it or haven't heard much of it, or still like hesitant to get into this sector, can you help us understand what BIM is from your point of view?
Yes, nice as common question, I would say, and of course I'm also very happy to answer. Considering that, I don't know now the people who are listening, what their level of education and preparation over BIM. Of course, BIM, I need to start saying that it's an acronym for Building Information Modeling, right? And permit me to make a little bit a brand out of it. And the brand would be something like with BIM, so a Building Information Modeling, it's still modeling. For describing what BIM and BIM workflow is, it is basically the approach of architects that instead of sketching drawings, and so pass their information, their knowledge through the drawing sketched, BIM, it is the place where the information, instead of being sketched, are modeled, and instead of being called well information, I would rather call them data. So in general, BIM is the transposition somehow of everything that was classically represented in our industry, in our discipline, with sketch, into a digital scenario. Okay, if I can quote, for example, some research, mostly from UK, that I'm reading about BIM. I'd like to describe BIM as the vital connection that actually permits the digitalization of the construction industry. So this is mostly how I would represent BIM for people that knows what it is and do not know. And also, you were saying very correctly, people that maybe knows and they are hesitant, or people they are already embracing, but they're not knowledge enough. And this is also an amazing separation that we are doing, and it is readable from a lot of paper. For all of them, wrapping up again the answer, I would say yes, that BIM is the gateway for the digitalization of the construction industry.
Excellent. And now talking, for example, on the topic that I was mentioning about people being hesitant, I think that most people find that there's a lot of misinformation still around the subject, right? But in your case specifically, how did you come to be acquainted with BIM? Did you have formal education on the subject, or was it something that you kind of like were finding around?
Well, back then there were not a proper formal education. At least in Italy, we were starting talking about that. Then, as you were mentioning before, I studied half in Italy, half in Brazil. and well, no proper formal education about BIM, but these things, the first approach to my career, that was teaching a software, that then, of course, it's also one of the most famous BIM software, it helped me. So I haven't had any such education. I've been introduced to BIM definitely during my university period, but the approach was mostly for, indeed, talking about architectural drawings, technical or architectural drawings. And everyone was crazy amazed by the fact that with BIM, that was how we were mentioning like this 10 years ago or more, your drawing plan and automatically the elevation and section are there, okay? So without any of this, this knowledge, I just approach the software mostly, I approached the BIM mostly from a software point of view. And that was what was happening 10 years ago. Nowadays, it is, of course, a total different panorama. And I'm also in front line kind of mentoring or sharing knowledge that I have all over the BIM, which is much more accessible and much more spread as well, also in the university.
Yeah, perfect. Yeah, I guess that's kind of like a common denominator for us that delve into teaching and stuff like that. That we didn't find BIM, but BIM kind of found us, right? Like teaching about Revit and stuff like that.
Yeah,
we kind of seep through that. And also talking specifically about software and computation and you know, like programming as well. At what point did you decide, I mean, yeah, I'm gonna start pursuing this field of computational design, or what was it that influenced your decision from like these early beginnings in your career to jump into computational design?
yeah. You know, I don't feel quite a jump. Sorry, no, not for correcting, but it's just for, as we would say in Italy, for just draw points on the eye, no? And I don't feel any jump, to be honest. I always been personally, on a personal level, of course, interested in computational design. That I was just seeing all around me, and at principle, I thought it was mainly concerning geometry finding, for example, or the ability of representing something that would have been manually unachievable, something like that. So with this curiosity in mind, I always, let's say, keep on studying on the side what I thought it was computational design, but I didn't quite know actually what exactly was. Of course, at principle, no, I was just being amazed by all of this nice projects that I was seeing around me. Then it happened on one day. I was in Brazil. I was studying there, you know, and with this friend of mine, Frederick. He just explained me a little bit what was his point of view over the computational design, and he also used to be architect, as a lead architect as well. And his suggestion back then was, you just need to eventually, if you are interested in that, don't approach it like it's a new software you have to know or you have to use. Like, for example, Revit. This one was the software I was using, of course, and I thought it would have been the same. I was kind of good in BIM because I knew Revit. So I was just trying to find my software to be good in computational design. It just explained me that computational design, it is not a matter of having the skill of a certain software, so to repeat certain paths, but it is an approach, a way of thinking. I mean, I'm pretty sure most of us already heard about the famous computational thinking, computational thinkers. And that's the way I somehow start realizing that this computational design, it was just a way of thinking for me. And back then I started studying myself, especially was Python. So it was a programming language for, in a way, establish a dialogue between me and the computer, becoming computational designer indeed. And the moment I found inside of BIM, or I found with BIM the possibility of connecting what was like architectural work, connect this architectural work with what was computational work, then I found out realizing I could have been a computational designer. And that's why I say there's not such a jump. Just think on me like an architect, total architect by education in two different universities, not even one, with this architectural education and a computational somehow passion that gave me the possibility of approaching the role of architect with the different tool. Then, of course, the roles, they need to have a name. And all over my career, I also changed the name of my roles. And I end up also at OMA, you were mentioning before, being computational design specialist. So yes, this is kind of my transition, but I still struggle in saying transition. I love to say I'm an architect by education with computational thinking attitude.
Yeah, perfect. I really, really love the way you said the computational thinking, right? Instead of like a role or like I guess like an education, like a set thing, right?
Yes,
So,
yes. Also because computational, it is something so broad. It's difficult to say I am a computational designer. Also because, and if I can quote, I knew we would have come to this point because of course there is this sort of a little bit of a fight or not, at least in architectural offices, but I'm afraid also engineering, between the computational designer, people that do want to be computational designer, pretending it is a different role. It can be considered totally, but yet our education, at least people with similar path as me, we still are architect. And the education of an architect as well as an engineer, it is absolutely versatile and versatile enough to then bend towards computational thinking, we are saying. If I can also make another quote that I note on a part, of course, was from Wikipedia. So it's absolutely public, okay? Wikipedia, when you type and search computational design, computational designer, so as a role, it kind of straight reminds you to a discipline in a way, which is computational science. And computational science, it states that it's just a field in mathematics. So it's kind of architecture, but not architecture as well, But it's a field in mathematics that is actually using advanced computational capabilities, which between humans in bar talk, as we would say in Italy, that would be a field of mathematics which strongly used computer. And that's computational science. That can be applied to a lot of different industries, including architecture as well as engineering. I'm always make the ping pong architecture engineer because, yes, I'm architect and I'm very happy to be so. But I see how our work it is actually glued together, architect and engineer. And I also worked back in the past and also currently with engineers just because I was applying this knowledge on this field of mathematics. It was useful for them as well. So this is how also I like to describe in a way the computational design and kind of specify how it enters inside of the architectural industry.
Excellent. Yeah, because I think that most people have this idea that computational design is probably just the parametric modeling, because we've heard a lot of like, for example, Zaha Hadid, how they apply it. But there's also another applications on industrial design. I've seen people do it also for like medical stuff, right? Like they imply computational thinking and design to solve their issues and objectives. So I really like that what you said about the applying the advanced computation capabilities to solve issues, right? To solve problems. I really like that rundown. So thank you for just giving us like not watering down, because of course we're not watering down because it's still difficult to compress, but for like that point of view. All right. So thank you for that. Now when it comes to applying it, like you said, on the architectural world, you have been part of some of the biggest architecture firms in the world. So based on your experience, can you tell us why big firms are adopting computational design in the present?
Yes, based on my experience, I will try to formulate an easier answer to this, because we would need another webinar just for talking about why to use BIM. So, well, the real reason, and this is the professional reason, totally, it is just the recognition from parts of this big companies, but not only big, the recognition of the returns that they can have over the investments. And the investment, it is of course leading and start delivering also BIM not BIM project, but BIM deliverables, BIM submissions, okay? And this I'm saying is a return on the investments, because on a global scale, of course, it's more than recognized that this digitalization over the construction industry, it is happening, and it will happen more and more and more and more. I didn't remember what was the quote, so I should even say, but we are estimating that in like 10 years' time, we will have the 100% of the digitalization also in our field, which is architecture and construction, sorry. We are also very well known for coming a little bit later, but this is the main reason. So I do want to answer to this question saying that big firms and good architecture and engineering firms, they are adopting BIM as they recognize the value of the investments of starting adopting this software. This is my experience on the higher level. So I can say this is my experience on the latest years, to be honest, when I was starting investing and having other kind of roles within my my practice a little bit higher. To kind of satisfy the curiosity of maybe most of the listeners here, I can also say that definitely one of the reasons of why to adopt the BIM, it is definitely the control that contractor, to be honest, but also architects and engineer, the control that they can have over the project, which is way more advanced, way enhanced, I can say. So I saw also back then in other firms, we were not even mentioning at the introduction, but how we manage with integrated company of architect and engineering and structural engineer, for example, to adopt BIM, because that was the best way for the cross-check between the different industries. And so the cross-check between the collaboration of the different disciplines. This is one of the best reasons I can also find, and is applicable to all the level, no matter the scale of the practice. The possibility of coordination, it is definitely yes, to my eyes, at least the top in class. And on the last level, eventually another reason, it's the time. Simple as this, is the time. Adopting BIM solution in a proper way, of course, this important disclaimer to add. Approaching and adapting BIM solution to different projects, it helps to reduce the time in production. Of course, it depends on the stages, it depends on the colleagues, it depends on a lot of things.
The training,
but,
right?
Yeah, the training as well, totally. I mean, I was saying it's an investment because, of course, architectural practice nowadays, we are still in this moment of transition. And so it's very easy to find someone hesitant in moving towards BIM, knowing that maybe all of this panorama of architect is working, they're not trained enough so far. And so at the beginning would be potential, if not sure, loss, at least in time. But on the long run, I'm more than confident in saying that this investment would come with a very good return for time-wise, so for office expenses and investment, and for client-wise, like project delivered in BIM, they gave more return over the time. BIM is a long-term investment that I would recommend everyone to do, to be honest. And it's already late if you didn't already.
Yeah, excellent. And reeling it back to computational design, I guess it would be something similar, right? Like the benefits and the attraction towards computational design, of course, would reflect on also time and the design creativity, like the workflow would also be changing, right? So like in your experience, has this been like the driving factor for companies to delve into computational design?
Yes, well, for sure. This is the driving factor for approaching computational design, and this is also, I can say, totally referred to also my career, to the experience I had in the office, in the offices I worked and I'm working with. It's for enhancing the quality of their work. Not saying that without computational design there is no quality, never there to, but saying that it's normal that architects want to improve themselves, right? In terms of also deliverables and quality of their results. And so common also it is that they want to eventually stretch the software they are working with or extend the capabilities of their tools. This is one of the first point in the description of a computational design job role. Extend the capabilities of the normal user level of any software. So this is important. And for extending the capabilities, I am mostly, of course, making reference to the quality of the production, the quality of the result, the quality of the project. So company, they are investing in computational design for enhancing their quality and time. This, again, an internal investment. Company want to spend, of course, less time for having at least the same result.
Yeah.
If not better.
Excellent. So a major part of computational design, like we were talking about, is including the newest technologies and another field, maybe, let's call it that way, that maybe architects have not been familiar with, which is programming. So we've seen this on wave of people wanting to get into tech jobs and people delving more into programming and coding and stuff. So you as an architect who is familiar with this, and for those of us who are maybe like still not aware of the importance of including coding and programming, can you tell us exactly how could including this type of skills could benefit architects?
Okay, how this type of skill can benefit architects? Well, on the very low level and super understandable for everyone, it benefits the moment it is helping, of course, in as I was saying, enhancing the quality and the repetition of eventual your work. Something that is very common, commonly state. It is how with computational design we have the best possibilities of iterate repetitive tasks that otherwise are meant to be done manually. This is again a very entry level knowledge, right? Thanks to the computational design, for example, you stop doing some repetitive tasks. I will just list one, for example. As you know, or most of us that of course you are probably no architect, product designer, engineer. Most of the time we have to stick to a specific naming conventions, for example, or most of the time we have to control the quality of our drawings of our project as well. And most of this control, they are just repetitive operation that if taught to eventually an intern, just making the example in the classic stage, this intern can perform over and over and over till the whole project is controlled. Now imagine that instead of repeating this operation, teaching to someone who's supporting you, you repeat this operation, teach them once only to a computer, which is repeating this operation so to give you the output, the desired output about the analysis or the checks or the renaming, so to have this naming convention I was mentioning before. As my math professor was saying, and this, 15 years ago, a great man as well, he was saying the computer is the fastest of the stupid. And we all were making a lot of fun of this. And he was not teaching informatics to us, it was just math. I don't know, sometimes he was coming with these quotes that I will never know if they are genuinely from him or read somewhere, but we were, of course, quoting him. And the fastest of the stupid. And dealing or end up knowing this fastest of the stupid, it helps a lot. It helps a lot, absolutely it helps, because the moment you can educate your, sorry for saying again, you're stupid, then it works and it goes very, very well. It helped me a lot. I can make you another example, very, very easy. And now I'm talking about engineering. I was working with this company, they were mechanical engineer. And as we know, mechanical engineer, they deal a lot with a lot of computation, a lot of calculation they are doing manually. And they were having in BIM, I mean, crazy amount of schedules for controlling all of their parameters. Then suddenly they had to export, I'm saying a very easy task, okay? They had to export all of this schedule into another software, was Excel, and the schedule were the table in Revit, that were designing in Revit and then recontrolling, cross-checking in Excel, all in there. And there were like hundreds of it. They didn't know how to do, well, they did, but they were making in budget 1 day work for exporting the things and giving the proper name. I was 23 years old, zero knowledge about mechanical engineering, but I kind of knew how to teach to this faster of the stupid that I was saying before. And I exported this 100 of schedule, and one was crazy happy. And this is a very classic application how also sort of computational design, it can help. I'm not talking now on any project realization, on any design. It looks like I'm not even an architect, if I make this as an example. But it is very good, in my opinion, for let everyone understand. Then another example just for architect, maybe this is also more juicy, at least that's what I'm experiencing with all of these talks I'm having also online. Another example, it is sometimes as designer, we know that a solution for example, optimizing the panelization of a facade can be found just by moving some points over this facade. So you have a facade which is not plain straight, but just move. You have it. And you want all the panel, of course, to be the same. That's because, yes, you are an architect and you are a designer, but you also need to provide a cost calculation of it. And the clients are usually happy when it's cheap, right? So an application of computational design, together with the architects, we define what are the constraints somehow. And then the computational designer talked or spoke with the programming language, indeed, to the fastest of the stupid. Sorry, just because I love my math professor, Roberto, his name. He managed to talk with the fastest of the stupid, so to apply not the design itself, not to draw the design that the architect ideate, okay, but he spoke to the fastest of the stupid, he spoke to the computer, so to apply their idea. And this is a great application of computational design, this time in architecture. We architects, we are free enough to find solutions that sometimes are hidden behind certain things. And for example, we have this facade, I was saying, with some dynamic points that in real world need to be fixed, and how to place these dynamic points on the facade. So to have a perfect panelization, this is something that architect gives the idea, but not necessarily has to make the thousands of
the options, right?
or position. And therefore, the computational designer can talk with the computer, so to make an application, and now I read it big on the screen, application, so to make an application of the architect's idea. And this is how it is mostly used in architecture, not just for facade, for everything. I just give a couple of examples now.
Yeah, perfect. And so talking about the actual applications of them, what are some of the software and tools that you use regularly in order to deliver this type of projects and tackle these design challenges?
Okay, now looks like advertisement, huh? It looks a little bit like advertisement. It is not. But working with BIM, okay, I can make it a little bit more open, better, sorry. Will not look like advertisement. I'm working with BIM, and of course, the end up result, it will be an IFC, which is the open format, no? Where everyone can actually work in. Now, personally, on my personal level, my education always brought me to use Autodesk Revit, which, as most of you know, it comes together with some package and some add-ons. One most famous is definitely Dynamo. That is the visual programming interface for Revit, which permits you the geometry definition as well as the data organization and management. Okay, so these are, for example, the two most used software I'm working with. That doesn't mean that they are only that. There are plenty of other solutions, and I already recently also worked for a project where that was a great record because all of the different consultants were having different softwares. And so we managed in a way to combine these all. Since we are now talking about computational designer or computational BIM design or computational science, whoever we want to talk, I like to answer to your question, which is the software you use the most, with specifying that independently from what the software is, parentheses, my basis is Autodesk Revit, we are using this computational thinking, this computational approach, this language for then talk to this computer as a computational designer. My personal favorite one, because it's very open source and can be found pretty much in all the software I worked with so far, it is Python, which is a computer language, as you know, but not only. That depends, of course. I just read a question, which is very nice. I don't know, maybe we'll come back on this later. I don't know if we have time.
Yeah.
But in general, okay, great. In general, it is Python, because this way I can answer to your question by being as much open as possible. Okay.
Yeah.
And it doesn't quite matter what the software it is. Then, of course, my preference is of course driving towards Revit and the application of Dynamo together with Python.
Excellent, thank you. And well, we're reaching the halfway of this webinar, and I would like to remind everybody that at the end, we're gonna have a Q&A session where you will be able to make all your questions. And if it's possible for you to start typing them so we can have like already some questions ready, it will be great. We're gonna pick some questions to be responded live, and at the end of the webinar, you'll be reached out by our experts to make sure that none of your questions go unanswered, all right? So let's continue talking about your experience and the projects that you've been able to deal with. So can you talk us through a project of yours that you're really proud of, or that you really remember the challenges and the learnings that you had from it? And how was computational design and BIM applying to it?
Yes, that's a nice question as well. There are, of course, a lot of projects I would like to talk about, also because honestly, I applied computational design in all of them, because it's a computational thinking. No matter what actually is the product, can also be the easiest of the example, but pretty much some tiny computationally used whatever. In terms of project, just for listing, of course, everyone needs to know that I can list projects as I'm working for companies that, of course, we have privacies and we cannot just publish or share general project. I would be happy to list the two projects that you also mentioned at the beginning of the webinar, which is the Feyenoord Stadium and the MKDW Vienna. They are both with OMA, and now I'm no more working with them in Rotterdam. I moved to Amsterdam, working with US Studio. I'm also working on a wonderful project here in US Studio, which we are almost at the end actually. And I experienced a very rich BIM setting up that we did interiorly for this project, but of which I cannot talk very much so far. You know why, of course. So moving back, how computational solutions have been used on these projects. Like, for example, now you're showing there KDW and Feyenoord Stadium. Feyenoord Stadium, bottom left, you see this seating distribution, and I'm so happy about that because we use computational BIM solution a lot in there, a lot, for a bunch of things. At certain point, also for calculating the quantities of material or painting, or a lot of solution for different areas that we were calculating in for different rules. I cannot list them all, but since there is a little icon in there, I also can take this stage for mentioning that this project has been brought to the Best of Autodesk University, as we used computational BIM design and more in detail an approach which it is called generative design. And for example, even though this project was entirely made in BIM, we extract some data out from other software through different platforms. This other software was Rhino and Grasshopper, and a different platform was Speckle. So to rearrange all of our distribution, for example, of the seats, and that was something we've been very proud of, because we managed to increase in that stage of the design the amount of seats by something around the 4%, a little bit more than 4%, if I remember, which is a lot. If you think stadiums that are counting more than 60,000 seatings, chairs, well, increasing by the 4% is not a game.
Yeah.
No. And it was very amazing. And we used computational design in this case. Of course, also the roof and a lot of other things, but I'm not sure that we have done time for talking about everything. And also was amazing there because also the team that we built up for this deliverable, it was very nice. Same as for KDW, this other project I want to talk about. This is a wonderful project, apart from of course, the brief and the context and the description you were doing before this one. As you can see, this facade solution, to me, and not just, of course, it talks a lot OMA in a certain way, this curved glass, for example, where the way this curved glass have been defined, it is very much computational. The idea is architects. We architects, we thought on the idea. Then this curved glass, how they are actually placed. And at a certain point, you see also in the corner, they just turn. But I can assure you, they are all the same, no matter actually how the plot was drawn, because the plot is there and stays.
Yeah.
We just need to make out the most possible, right? These whole glass were a computational solution that actually permit then having the best out of it, taking in consideration also other parameters, like for example, the reflectance of the glass, that you can easily imagine, if you haven't already seen, that if you are behind of a curved glass, then everything looks not properly right? There's the reflections and things, they are a little bit strange. So we're also adding this parameter inside. And I'm so proud of it. But it's not the only thing. And here I want to make a very big congratulation and recognition about the team I worked with, because I was working together with this team on the project KDW. On the same time, I was working also on the stadium. And as you can imagine, the size of the two, they were pretty different, right? Even though the size of KDV was much smaller than the stadium, all the team was extremely enthusiastic about this application. And so also inside, for the actual drawing, and I'm talking about 2D drawings of this project, we used a lot of computational solution for automatize operations such as floor plan annotation or elevation representation or graphics or more and more and more. Then on the right of this image, you also see a little bit of a heritage facade. This is part of the project. And also the way we were dealing with it, it was all, of course, architect approach, so normal approach, manual approach, but all the data, but then we kept everything under control, were driven by strong computational solution that was keeping everything under control and with standard of highest of the qualities. It was very nice.
Excellent. Thank you for guiding us through these projects and your experience with them. And I want to quickly jump on what you mentioned previously before about computational BIM. So let me just go back here. What does exactly, well, not exactly, but can you give us a rundown of what does a computational BIM specialist do?
Yeah. Computational BIM specialist do, again, in the field of architecture, because it can be so broad. So also the BIM has different fields, you know? In architecture, what the computational BIM specialist does is actually the role with analytical enough for approaching a problem, an issue, understand it, find the key point of the issues, and then solve it by applying a computational solution, which, as we were saying before, a stronger computer mathematic approach. So what a computational BIM designer is doing, it is actually analyzing a problem and solving them by applying computational science. It is very similar to the architects. They analyze problem and they solve it, right? But not in a computational way. This is what computational BIM designer they're doing. And again, both under geometrical point of view and under data point of view, because we are talking about BIM. And as I was saying before, BIM is the gateway for the digitalization of the construction industry. And this is actually, I am very thankful for that, because it's mainly thanks to BIM that I managed to enter this career of computational design, because I really saw the data behind the construction and in the construction, of course.
Yeah, perfect. So, I mean, we've mentioned and we've acknowledged the fact that both BIM and architecture are like gigantic and broad fields, right? Like also computational design. So we cannot really like pinpoint exactly what we do, because there's many branches of how professionals can go, right? But talking through a career perspective, at least from your point of view, how would you define, or how you do differentiate between the roles of an architect and a computational designer? Do you think they are very different to each other, or there are similarities there?
I'm an architect by education, computational designer by passion, somehow, and it's tricky to split them. If I need to split, of course, I would just say that the computational designer is the one more interested towards software implementation and bold caps lock research. Computational designer.
Yeah.
This is how I would
precise and concise.
Yeah, well, just also because otherwise it's very difficult. I like to say it's difficult to split computational design and architects, because they are kind of do the same, analysis and solution, but one with computational solution, the other one not necessary. And this computational solution implies a lot of research, lot of software implementation.
Excellent. So now talking about the way, like we've talked about your experience, we talked about how was your approach to computational design, also BIM. So how can you start? In this case, for example, in the present day, you are also joining us at 1:X as a mentor at the Computational BIM course, which is called the Computational Master, 1:X Master Computational Design course. And you have been part of, integral part, I would say, of the development of this course because you were part of the design of it, right?
Yes.
So what can the students that might be interested in delving into this career path expect to learn from you? And what are you looking forward to the most with this course?
Yes, I like to make this half metaphor, half not. So this answer, it is something like, I'm really looking I'm really looking for these courses where to teach and explain how and why to talk with the computer. So what I'm expecting as a big giveaway out from the course, it is, well, definitely the possibility of interacting with the computer. So to give out from this tool that all of us we are using the most and the best possible, of course. In a way, and to make it a little bit more as a brand, I am expecting to see people following this course, understanding how to turn their work and their approach to work more challenging and definitely innovative.
Excellent. So finally, and wrapping up with this conversation, what is a piece of advice that you would give to the young professionals, the young architects or engineers maybe, who are interested in learning computational design?
It's the same that I received 10 years ago from one friend in Brazil. More or less 10 years ago. Now I just shoot. And it is definitely don't focus on becoming good at one tool. The purpose is the first advice I would say for people that are starting this career. Don't focus, don't close yourself in a tool saying I need to become good at this, doing these things. It's way better to step a little bit out of this perspective and start understanding and focusing on how to know the tool rather than becoming good at. And of course, you will become good at as well. But as a computational designer, you will be much more interested in knowing how a tool it is working rather than how to work with a tool. This is the suggestion I would give. And to be very, very practical, if I can also, because it happened long ago also to me, someone has been straight to the point, know the tools, not how to use the tool, but how to read and talk with the tool. Study a programming language. In my case, was Python. That's the tips I would give to someone who's starting the career now.
Perfect. Yeah, I really, really love that. Focus on not focus on the tool, because that's something that many people do, right? Like they only delve into the tool and think that the tool is going to define everything else.
And then suddenly there is a limitation and everyone gets stuck. Just understand the tool and use as much as you want. When it is not enough, then bend it or do something different. Be computational.
Yeah, excellent. So wrapping up, these are some of the experts that are joining us at our Master Computational Design course at 1:X, which, as you can see in the screen, Giuseppe is also a part of this team of mentors of a multidisciplinary, I would say, because not only they are from different companies. There are different paths in their career, but also different countries. So as you can see, this is a very good conversation that we had. Thank you so much, Giuseppe, for taking the time to speak with us and teaching us much more about computational design and your experience so far. So I really thank you for being here today.
Thanks. No, it was
so before
absolutely my
we
pleasure.
finish, yeah, thank you so much. So before we finish this conversation, I would like to check out some questions from the audience. So please go ahead and raise your hand with the reaction of Zoom. And if you're able to, please turn on your microphone because we want to hear your voice and see what you have to say. All right. And like I said before, if we don't get to your question before the webinar ends, our experts will be touching base with you further via email, and we'll make sure that none of your questions go unanswered. All right. So Deeptanshu, can you turn on your microphone?
Hello, I'm audible.
Yes, we can hear you.
Yeah. I want to ask, I'm actually currently switching into BIM. I'm experienced 3 years architect. So what will be your suggestions and what will be a kind of checklist for upskilling into a successful computational designer? What should be it?
You are switching now to BIM and you're asking how to switch to computational design.
Yeah, how should I be a successful computational designer? Actually, I'm going to learn BIM. I'm switching into this field of architecture.
Yeah, well, switching to BIM, you will realize how all of the work will not just around drawings and modelization. It will be also a lot of data. My very straight tips and suggestion would be just to dive a little bit deeper in these things of data and use BIM for understand how to manage data. Indeed, for data, very practical. I'm talking about parameters and values, classification, quantity takeoff. These are all data management that can teach you by using, of course, can teach you how to start thinking in a computational way. So the fact they are switching to image is definitely good, and focus on the data that stays that comes together with BIM. This is the suggestion I'm thinking about, actually.
Excellent. Thank you, Giuseppe. Yes, totally. Thank you, Giuseppe. Thank you, Deeptanshu. We're going to go for the second question from, let's go and pick one from the chat by Alexandra. What do you think about Rhino inside Revit? Also, to add to this question, what do you think about Dynamo Grasshopper combination?
Okay. Well, the two questions are actually coming pretty much together, of course. And what do I think? I think it is extremely difficult because needs to be used with good background knowledge. I see Rhino inside and in general the communication between Rhino, Grasshopper and Revit too much formal in a way. Like a lot of professionals, colleagues of us, they are just using this as sort of gapping a bridge and approaching the BIM as it is Rhino. And it is absolutely not the case. So I see it as something good because it gives you the short-term result that you are looking for. Your Revit geometry into your Rhino geometry into Revit. But just watch out because then the final result that is going to be a BIM deliverables, it might be way different than that. That said, the developer of Rhino Inside is Saisan, which is the same developer of PyRevit, which is the best invention of the last, I don't know, I guess it's 5 years in the architecture industry for Revit at least. So also I need to say that I highly appreciate the old tools, and I have a great opinion over that. It's just the best way to use that. Those tools in general, it requires more back knowledge. Like, for example, to make it very practical, in order to translate some geometries, talking about wall, okay, from one model to the other, from a Rhino to Revit, by using Rhino inside, it is totally okay by using the tools, but it is not just the application, because you need to know the starting point, which is your 3D geometry well, actually it's line in this case, but in Rhino, and you need to know what you need to achieve in Revit. So I think are extremely powerful, but a tricky solution. Help for the short-term distance, difficult for the long-term investment that I was mentioning at the beginning. Just difficult. Not saying it bad. I would never talk about it.
Excellent. Thank you, Giuseppe. And now for our final question from the chat, which I think is a little bit interesting. From Pavitra, what do you think is the future of computational BIM's future? Well, I guess to repeat the word there. How is the reason for, or the narrative for the crazier geometries achieved in the structures justified? Yeah, so I mean,
did I get the question
I guess
right?
that, yeah, I mean, can you like reword it?
Oh, okay. So I want to know what's the why between the crazy geometries that's been achieved. So the narrative or the reason behind the geometries that's been achieved and how it's justified. That's the second question. First question, I think it's pretty clear except the future word.
Yeah.
Cool. Thanks.
Excellent. Thank you, Pavitra.
The future tool, I wish I can know. If I knew, I would have already started using. But I don't know. In general, now we see a lot of AI implementation. Also, recently it happens for Revit that it comes with these AI tools so that you can start implementing a little bit of machine learning as well inside of your designing stages. And I totally see this as a possible future, not even so far, to be honest. And it is definitely something I would have a look at, and I am actually doing so, kind of connected with the design. This then for next post design, we are talking about, of course, digital twin. This the future, even though most people they're already implementing it. And for digital twin, I'm mostly talking about the facility management. So designing and building up a project digital that it will be helpful and of crucial vital importance also towards the whole life cycle of the building, for the maintenance on one side and for the sustainability and the performance of it. So, for example, the life cycle analysis, pre-construction, during construction, post-construction of something. This is definitely the future, also because we highly need it on a global scale. And for the second question, it's difficult to answer. What's the need of this crazy shape? You know, when we are designers, sometimes you don't need a reason for it. But in general, to answer this, I can totally assure you that in general, these shapes are not like in the Simpson cartoons, born because of Frank Gehry was scratching a piece of paper and shooting on the floor. They are most likely, and most of the time, results of analytical and mathematical operation that end up realizing with the best solution for certain analysis, for example. Analysis that can be environmental or can be costs analysis as well. This is the main reason it stays behind it. And well, then I'm Italian, no? Let's not forget architectural style. You go in Florence, you suddenly live in the Renaissance age. Now I'm in Amsterdam, it's totally different. I make some kilometers, I became Flemish. You know, it's just architectural direction. It's important to recognize it as well.
Excellent. Thank you, Giuseppe. And thank you everybody for joining us. Unfortunately, we don't have more time to take on your questions live, but like I said before, our experts will get in touch with you to make sure that none of your questions go unanswered. So once again, Giuseppe, thank you so much for taking the time today to speak with us and to speak with all of our audience. I will remind you that you can watch this webinar once it's live on YouTube, on our YouTube channel of 1:2X, so you can go back and check what we talked about today. And well, thank you everybody for joining us. We'll be seeing each other in the next webinar. Thank you, Giuseppe.
Thank you everyone, very much, my pleasure.
See you soon. Goodbye, guys.
Bye everyone.